Hello amazing humans, welcome back to the HR Academy's channel, where maths isn't scary, just weirdly fun. Today we're solving trick questions from actual past exam papers, and I promise you, they are not as bad as they look. So grab your pen, your calculator, and let's get to it. This question comes straight from the 2022 final exam, and it's the type of question they love to sneak into paper 2. So here we need to solve for x. 2 sine x minus 1 is equal to 0, where x is in between 0 and 360. We now need to use our algebra rules to find sine x alone. So we need to move 1 to the other side. It becomes 2 sine x is equal to 1. But I want sine x alone. We need to get rid of the 2. So we need to divide each side by 2. So we write it like this. 2 sine x over 2 is equal to a half. That becomes sine x is equal to a half. But the question is solve for x. We want x alone. So you take your scientific calculator, you select shift sine a half, which gives you 30. So x is equal to 30 degrees. In the question, we want x where it's in between 0 degrees and 360 degrees. So we need to look at our cast rule. We know 30 degrees is in the first quadrant and sine is positive. That half there, it is positive. So it's in the first quadrant. So we need to look for where sine is also positive again. So we know that sine is positive in the second quadrant. So to get the answer in the second quadrant, we say 180 minus x. So the x that we got was 30 degrees. So it becomes 180 minus 30 degrees, which gives us 150 degrees. Therefore, our full answer is x equals to 30 degrees and x equals to 150 degrees. This question comes from the 2021 final exam, and here's the trick. You need to solve for 2x first, then divide your answers by 2. It's like the maths version of don't forget the fine print. We need to find x when cos 2x is equal to 0 and x is in between 0 degrees and 360 degrees. So firstly, you need to take your calculator and punch in shift cos 0. You should get 90 degrees. So we're going to use the general solution to get the answer. We then say 2x is equal to 90 degrees plus k 180 degrees, where k is an element of an integer, right? So we don't want the 2 next to the x. We want x alone. We have to divide each side by 2. It becomes 2x over 2 is equal to 90 degrees plus k 180 over 2. The 2's cancel each other out, which leaves us x alone. Then on the right hand side, we say 90 divided by 2, which gives us 45 degrees, plus k 180 divided by 2, which gives us k 90 degrees. So that means x is equal to 45 degrees. And then we need to keep adding 90, but it cannot be bigger than 360 degrees. So 45 degrees plus 90 degrees gives us 135 degrees. Then when we add another 90 degrees, it gives us 225 degrees. Then we add another 90 degrees, it gives us 315 degrees. Then we add another 90, it gives us 405 degrees. But the 405 degrees is bigger than 360 degrees. So x cannot be equal to 405 degrees, which leaves us with x equals to 45 degrees, x equals to 135 degrees, x equals to 225 degrees, and x equals to 315 degrees. Now, we have to prove an identity. This is the maths version of Prove You Love Me, except this one's actually provable. This question comes from the 2021 final exam. We need to prove the identity cos x plus y times cos x minus y is equal to cos square x minus sine square y. We will start with the left-hand side. The left-hand side looks similar to the identities that you will find on your formula sheet. Using the cos A plus B identity, we will change the cos x plus y to cos x cos y minus sin x sin y. And using the cos A minus B identity, we will change cos x minus y to cos x cos y plus sin x sin y. If we look at that sum, it looks like the identity called the difference of squares. In other words, x squared minus y squared is basically equal to x plus y, x minus y. So that would make the left-hand side to be cos square x, cos square y, minus sin square x, sin square y. And that is the difference of squares. Now, if we look at the right-hand side, the cos is together with the x, and the sin is together with the y. So we need to get rid of the cos square y because the cos square x is with an x. So that cos square y becomes 1 minus sin square y. We're basically using the sin square x plus cos square x equals to 1 identity here. And then the sin square x becomes 1 minus cos square x, which basically gives us cos square x 1 minus sin square y minus sin square y 1 minus cos square x. Now let's get rid of the brackets by simplifying it. If we get rid of the brackets, it becomes cos square x minus cos square x sin square y minus. So I'm just going to open a bracket so that we don't make errors, especially when it comes to positives and negatives. So minus in brackets sin square y minus sin square y cos square x. Let's now get rid of that bracket. So that becomes cos square x minus cos square x sin square y minus sin square y plus, because a negative times a negative becomes a positive, plus sin square y cos square x. So there's two terms that look alike there. The cos square x sin square y and the sin square y cos square x, they basically look the same. They cancel each other out because it's minus cos square x sin square y plus sin square y cos square x. Now we're left with cos square x minus sin square y, which is equal to the right-hand side. If only relationships were this simple, but hey, at least maths is loyal. We've got this juicy question from the 2016 final exam, and it goes like this. Given sine 16 equals to p, determine the following in terms of p without using the calculator: sine 196 and cos 16. Right. Question 1. Sine 196. Let's unlock the trig vault. First spot the quadrant. 196 is in the third quadrant and sine is negative in the third quadrant. Only 10 is positive in the third quadrant. Since the third quadrant is 180 degrees plus x, the 196 degrees becomes 180 degrees plus 16 degrees, and that will make it negative sine 16 degrees. And remember that sine 16 degrees is p, which makes sine 196 degrees equal to negative p. Next up is cos 16. Let's use the SOHCAHTOA rule. Using that rule, we know that sine theta equals to opposite over hypotenuse and cos theta equals to adjacent over hypotenuse. So if sine 16 equals to p over 1, that makes the opposite equals to p, the hypotenuse equals to 1, and we need to find the adjacent. To find the adjacent, we need to use Pythagoras. We know that hypotenuse square is equal to the opposite side square plus the adjacent side square. We are looking for the adjacent side. So adjacent side square equals to hypotenuse square minus opposite side square, which is equal to 1 square minus p square, which makes a square equals to 1 minus p square. but we want a alone, so we need to square root both sides. So a is equal to the square root of 1 minus p squared. Therefore, this makes cos 16 equals to square root of 1 minus p squared over 1, because that's adjacent over hypotenuse, which is equal to just square root of 1 minus p squared. At this point, I'm not saying I'm a trig magician, but I did just pull a square root out of thin air. And if someone tells you you'll never use this in real life, just say, clearly you've never tried to pass grade 12 maths. We will now be tackling another question from the final 2016 paper. We need to simplify cos A times cos 90 minus A over 1 minus cos square A. Firstly, let's tackle the familiar phase here, cos 90 minus A. Now, I want you to channel your inner trig identity ninja. Remember this golden rule. Sin x is equal to cos 90 minus x. Also, cos x is equal to sin 90 minus x. So because this is cos 90 minus a, it becomes sin a. So the numerator just becomes cos a times sin a. Now let's tackle the denominator, another identity. Trig functions love swapping identities more than celebrities change outfits. Let's remember another identity. 1 minus cos square x is equal to sin square x. So that means 1 minus cos square a is equal to sin square a. That's our denominator. So now we have cos a times sin a over sin square a. Let's separate the sin square a to just make this simpler. So we now have cos a sin a over sin a sin a. Sin a and sin a cancel each other out. So all we have left is cos a over sin a. That can be your final answer. Or remember that sin a over cos a is equal to tan a. That would mean cos a over sin a is equal to 1 over tan a. Let's take it up a notch. We now have a question from the final exam from 2024. If cos alpha is equal to p, express the following expression in terms of p. Cos alpha over 2 minus 45 degrees sine alpha over 2 minus 45 degrees over 2. In the formula sheet, there is no exact identity that can help us find cos x sine y only. But we can find an identity to mix it up a little bit, where we can make something cos x sine y only. The best identity to look at is the sine 2x is equal to 2 sine x cos x. But we want sine x cos x alone without the 2, so we need to divide each side by 2. If we divide each side by 2, it becomes sine 2x over 2 is equal to 2 sine x cos x over 2. Those 2's on the right hand side, they cancel each other out, which gives us half sine 2x is equal to sine x cos x. Now we have an identity looking like our sum there. We're looking at the alpha over 2 minus 45 degrees as an x. Therefore, cos alpha over 2 minus 45 degrees sine alpha over 2 minus 45 degrees is equal to half sine 2 alpha over 2 minus 45 degrees. And if we multiply that 2 into the bracket, it gives us half sine alpha minus 90 degrees. Now, since we've simplified the numerator using an identity, we now need to do the whole sum. It now becomes half sine alpha minus 90 degrees over 2, which is sine alpha minus 90 degrees over 4. There's now a familiar face there, the sine alpha minus 90 degrees. Alpha minus 90 degrees goes to the fourth quadrant, and in the fourth quadrant, sine is negative. So this becomes negative cos alpha. Let's not forget to put the denominator. so it is negative cos alpha over 4. Since cos alpha is equal to p, the answer will be negative p over 4. And there you go. Past paper questions solved with less stress and more smiles. If you found this helpful, smash that like button like it's your maths anxiety. And subscribe for more videos just like this. Drop a trig boss in the comments if you nailed it. Download today's matching worksheets below. And remember, the more you practice, the luckier you get in exams.